Hi guys, welcome back to Learning with Lilia, and today we're going to do 2.4 chemical formulas and nomenclature. When naming chemicals and compounds, we're going to be using the IUPAC. That stands for International Union of Pure and Applied Chemistry. This was a bonus question on my test, so it'll probably be on your test, anyone that has my old class. Okay, so we typically use mono, which is 1, di, which is 2, tri, which is 3, tetra, which is 4, and so on. Looking at ionic compounds. So, binary ionic compounds, it's made of a metal and a nonmetal. So when you have a metal and a nonmetal, the metal name is unchanged. This is with any metal, it is unchanged. Then when you get the nonmetal, you're going to replace the ending with IED, which is a suffix. So if we have potassium and chlorine, it's going to be potassium, because it's a metal, it stays the same. Then we have chlorine, which is now chloride, because you take away the ending and put IED. These are some of the examples. Pause the video if you need, and I'm going to tell you the answers in 3, 2, 1. Let's get into it. Okay, so we know Na is sodium, and sodium, I'll do green. So we know sodium is Na, so we are just going to do sodium. My bad, I can't spell. Sodium, and now we have iodine. So we're going to go IO, and then D, and then you go IED, replacing the ending with IED. Now we have beryllium. Because beryllium is a metal, it does not change. And we have oxygen. Okay, so now we're going to put in the suffix of IED. We don't add anything else because that's how it's done. Okay, so we know Ca is calcium. And we know N is nitrogen. We're going to go Okay, so we go nitride. It makes more sense than nitrogide or whatever. So this is how it's spelled, nitride. So now we have calcium nitride. On to the next one. That Li we know is lithium and is a metal. And we know sulfur is S, but now it's going to be sulfide. We're taking that ending again and adding IED. Okay, we're going to go on to this. We're going to actually write the lettering. So strontium we know is SR. And we know S is sulfide is S. And that's it. You don't need to balance it because it's balanced. Barium fluorine. We know barium is Ba. And we know fluoride, is F. But barium has 2 electrical charge, and fluorine has 1. So we're just going to do a swap. We're going to do a swap. So barium gets 1 and fluorine gets 2. Because 1 is just 1, anything multiplied by 1 is 1, we're going to leave 1 out. Now to potassium oxide. Well, we know potassium is K, oh my lord. We know potassium is K and oxygen is O, but now we have 1 charge for potassium and 2 charges for oxygen. So all we're going to do is switch the charges, and potassium gets 2. Hopefully that makes sense to y'all. Alright. Okay. Okay, we know lithium is Li, and we know hydride is H. And lithium has 1, hydrogen has 1. We're all good. Now we have sodium, which is Na, and we have nitride, which is N, which is nitrogen, so N. But now sodium is 1 and nitrogen is 3. We gotta switch. And now it's going to be Na3N. Now we are going to do ionic compounds with multivalent elements. So copper has... Okay, let me explain what multivalent means. Multivalent elements are elements that have two charges. Like copper has a charge, two charges, which is 1 and 2. You can find many of these on the periodic table. It's typically in the middle. So you could write copper as copper 1 or copper 2. We write it in, Roman numbers, Roman numeral numbers. So magnesium 2 chloride would be MnCl2. Let's do some examples. Okay, so here are some examples. Pause the screen if you need to write all these out and double check if you're right. I'm going to give you the answers in 3, 2, 1. Okay, so we know tin is Sn. And we know fluoride or fluorine is F. Now, because there's 4 tin and 1 fluorine charge, they're going to switch. So now fluorine will get the 4 and Sn will get 1. On to the next one. Iron we know is Fe, and phosphide we know as P. Now we have a charge of 3 and a charge of 3, so it's all written out for you. Now we know cobalt is Co, and we know nitride is N. Cobalt has 2 and nitrogen has 3. So if you go 2 and 3, we're going to swap it, which is now 3 and 2. So that's going to be your final answer. Now we have lead, which is Pb. And we have oxide, which is oxygen, which is O. Lead has 2 and oxygen has 2. So that's the balanced equation. Well, I shouldn't call it equation, but it's balanced. Okay, we know Fe as iron. And we know Cl is chlorine. But now because it's ionic compound, it's chloride. We gotta find the electrical charge. If there's 2, chlorine has a charge of 1, and iron has a charge of 2. So it's going to be 2 iron 2 chloride. We know, iron again. But now we have a charge of 3 on the chlorine, which means iron has a charge of 3. And we know chlorine as chloride because of the IED. Okay, we know Cu is copper. We're going to leave a bracket there. And we know sulfur is S. So we're going to write sulfide because it's an ionic compound. Oh, I wrote that wrong. Oopsie. See, even I make a mistake. I kind of messed up the previous take, so we're going to do this. I cut it, and we're going to do this again. Okay, so how do we know which number is copper? Well, we know sulfur has 2, and copper could have 1 or 2. So if there was a 2 here, then that would mean copper would be 1, because you changed the charge. If copper was 1, there would be 1 here and a 2 there. But if copper was 2 and 2, we kind of just erase these, because 2 and 2, it's the same number. It was 2 and 3, we would write both. If it's 1 and 1, we would write none, because 1. But yeah, we know copper is 2. So we know Sn is tin, bracket, bracket, and we know S is sulfide. That's a very bad S and L. So how do we know which charge is tin? Well, Sn has, Sn only has nothing there, and sulfur has 2. So sometimes if you have multiples like 2 and 4, or you would never see 6, but 2 and 6, then you can kind of reduce it to basically 1 and 3, because you're dividing it by 2. So in this case, Sn, or tin, is 4, and sulfur is 2, because if you switch the charges, it would be 2 and 4, but because there is no 2 here, and there's no 4 here, you're going to reduce it, go over 2, which is now 1 and 2, which is the original equation. 4. Okay, Pb we know as lead. And we know SO4 is sulfate. So we know that Pb has a charge of at least 2. But sulfate has a charge of -2, which means Pb cannot be 2, because then this one would cancel out. So this means Pb has to be 4, because remember, 4 divided by 2 equals 2. 2 divided by 2 equals 1. And that's what happened here again. Okay. Compounds with polyatomic ions. The acronym my class used was Nice Students Pass Chemistry Class. And we remember the 1, 2, 3, 2, 1. Then we remember 3, 4, 4, 3, 3. So basically, N is nitrogen, which stands for nice in the Nice Students Pass Chemistry Class. Then has a charge of -1 and has 3 oxygens. Now, what is the charge for... Okay, so I'm going to give you a question. What does S stand for? It is sulfur. But now, what is the charge? -2. How many oxygens are there? 4. Okay, I'm going to do this one. You guys got to say it. Hopefully you get it right. This is not for me. This is for you. Remember that? So say it out loud. Do what you have to do to remember this. But remember this. What is the charge of P in pass? -3. How many oxygens does P have in pass? 4. What does P stand for in pass? Phosphate. Okay, next one. Chemistry. What does the C stand for? Carbon. What is the charge on it? -2. How many oxygens does it have? 3. Next. What does the Cl stand for in class? Chlorine. What is the charge? -1. How many oxygens does it have? 3. Good job. Now, I'm going to look this way. Now, what is the acronym? Correct. Nice Students Pass Chemistry Class. Be that nice student and pass chemistry class. Okay. So, polyatomic ions are ions that don't separate during a reaction. This stands for reaction. Example of this is CO3 or carbonate. OH is hydroxide. This has a charge of -1. What does this have as a charge? -2. Good job. Okay. Let's do some examples. Pause the screen, write everything down if you need to. But I'm going to give you the answers in 3, 2, 1. Okay, so we know this as ammonium, which I believe is spelled I think it's a double M. Let me double check. It's a double M. Alright. Ammonium. What is this? Chlorate. Oh, I spelled that wrong too. Not my day. Okay. Al is aluminum. Aluminium, as I like to say. Oh, it doesn't have a double M. Watch out for that, because I always spell aluminum wrong. What is this? That's sulfate. There are 2 ways of spelling sulfate as well. SLPHATE or F. It doesn't matter. It's the same thing. So I might write it both ways. We know Pb is lead. Okay. Let's quiz you again on the previous. What does the charge of Pb have? 4. So you're not 4. And then we know NO3 is nitrate. Okay. What is Cu? That's copper. What is the charge? Well, considering copper could have a charge of 1 or 2, and OH has a charge of -1, copper has to be 1. Now, what is HO or OH? That's hydroxide. I said that so weirdly. Okay, now we're going to get into doing the letter form. Iron is Fe. Hydroxide, we're going to have to put it in brackets. And we're going to put a 3. This is not the same as this, because you're saying now Fe, O, and H has 3, when we actually mean there are 3 OHs. So 3 oxygen and 3 hydrogen. Okay, what is calcium carbonate? Well, we know Ca is calcium, and we gotta put brackets. Carbonate, because I don't know if it's has a charge. Carbonate has a charge of 2, and calcium has a charge of 2 as well. So this is the final answer for... Okay, magnesium. We know magnesium as Mg. And then we know phosphate is PO4. We're going to have to put some brackets around these, because this has a charge of -3, and Mg has a charge of -2. We can't reduce, or we'll get a fraction of, I think, 3/2. Yeah, we'll get a fraction of 3/2, which is not possible to have a fraction of. Okay, copper is Cu. Cyanide now. Cyanide has a charge of -1. It will be on the back of your periodic table, all the charges, all the different compounds that stick together. But yeah, cyanide is Sn. So we have variables now. As you saw before, we used 8, which had 3. Oh, I can't write on this. Which has 3. Now we have, what if there's 4? Like if carbon had 4 oxygens, what about 2? What about 1 oxygen? So now we get into that. If it's normal, so if it's the 3, 4, 4, 3, 3, then it's just 8. Like chlorate. What about adding 1 oxygen? Now it's per8. An example is this is perchlorate, which has Cl4. It still has the same charge. Now, what if we remove 1 oxygen? Well, it's going to be ite. Chlorite, which is Cl2. Still has a charge of -1. What if we remove 2 oxygens? It would be hypoite, which now means hypochlorite, or ClO. Still charge of -1. Okay, hydrates. We're going to get on to hydrates. What is a hydrate? It's when weakly bonded water molecules are present in an ionic compound. It's considered a hydrate. When water is removed, it's called an anhydrous substance, or anhydrous solution. It's solution, not substance. An example of this is sodium carbonate times 10 water, or hydrogen. Oh my lord. Dihydrogen oxide, which is sodium carbonate deca, which is the number for 10. If it was nona, then it would be 9. But it's not, it's 10, so it's deca. Hydrate. So yeah, that's how you do that. I think we have some examples. Okay, so here's some examples. We know this is copper, right? So what is its charge? Well, sulfate has 2, -2, and copper can have 1 or 2, which means it's 2 because there's no bracket putting 2 and 2. Oh, wait. We know this is 2 because there's no bracket saying there's coefficient. We know this is copper 2 because there's no 2 on the carbon. Oh my lord. I cannot speak. Okay. Now what is SO4, which is sulfate? And now how we name this is hexa. No, hexa's wrong. Hepta? No. Penta. Sorry. This is penta. See, even I get it wrong. Heptahydrate. So now this is copper 2 sulfate pentahydrate. I wrote that weirdly. This is all like one, not that big of a gap. Okay, cobalt, which is CO. Chloride, which is I just do Cl2 because cobalt has a charge of 2. Chloride has a charge of 1. And now we have hexahydrate. We're going to multiply that. 6 is for hexa. Remember, hepta is 7. Penta is 5. Hexa is 6. Hydrate, which is H2O. That's how you do these. Molecular compounds. Molecular compounds are covalent compounds, a nonmetal plus a nonmetal. Prefixes are, as I said before, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. You have to remember this. This is very important. Let's do some examples. 2, 1. Okay, nitrogen has 2, so this is dinitrogen. That's not how you spell nitrogen. This does not get an IED because this is the starting. Then oxygen has 5, which is penta. Pentaoxide. I believe you keep the A, but I don't know. It could drop the A. I forget. Okay. B is boron. We don't have to write monoboron. That's just kind of for the ending. Like fluorine has 3, so it's going to be trifluoride, not ene. Ide, remember your IED. Okay, we know C is carbon. Doesn't get anything. Now we know chlorine is chloride, but we know 4 is tetra. You know, like Tetris. Tetrachloride. Okay, we're going to move on to these. Sulfur is SO2. Because di, and then we have oxygen. Di mean 2, oxygen mean oxygen. Now we have nitrogen, and we have tri, which is 3, and we have hydride, which is hydrogen. This is actually ammonia, not ammonium. Ammonia. Ammonium is with 4 hydrogen. Now we know carbon and monoxide, which is just O. Diatomic molecules are molecules that come in 2, which is di meaning 2, atomic meaning atomic, molecules meaning molecules. So iodine comes in a form of 2, nitrogen comes in a form of 2, hydrogen comes in a form of 2, chlorine comes in a pair of 2, bromine, oxygen, you get it. They all come in forms of 2. There's another thing that's in the triatomic molecules, which is ozone, which is O3. You will find this in the ozone layer. You will have to know that. Okay. So we have this is 7, right? No, this is 6. Which one did I forget? Fluorine comes in a pair of 2 as well. The brief or the acronym is I've never had clean briefs on Friday. That's what it says in the notebook. I hate that. I just kind of remember it. You should remember it because this is very important. If you have an equation and you just have like O plus H, you got to know that's 2 and 2. Binary acids are compounds that dissolve in water, release hydrogen ions. So H. We use hydro and ic to signify this. So you have HCl with the AQ. It's going to be hydrochloric acid. You got to add that acid. So it's hydro, chlor, which is just chlorine. Add that ic. And then we have that acid. Okay, on to oxyacids. Normal, so the normal, which is 8, like chlorate, is now going to be turning into ic acid. If you have one extra oxygen, which is per 8, you're now going to be per ic acid. If you have one less, which is the ite, you're going to have us. acid. Remember your acids. If you have 2 less, it's going to be hypoous acid. Okay. Let's do it. Pause the video if you need, but I'm going to start doing them in 3, 2, 1 as I get a new color out. Okay. So this right here. Okay, this right here is nitric acid. We know this because there's an H. This is a polyatomic. And there's a 3. We also have an AQ. Now we have HNO4. There's one more oxygen, which is going to be per nitric. Oh, I didn't add an I. Oops. Nitric acid. Now we have H still, and we have 2, which is 1 less. So this is going to be nitrous acid. Now we have 2 less oxygen, and we still have that hydrogen. You always need that hydrogen, which is now nitrous acid. Comment down below how many you got. If you are one of my friends and you still need help, come text me. I only give this to my friends that I know will respect me for doing this, because I'm trying to help you here. If you don't, then you don't have to watch this. I'm just trying to help my friends. But yeah.